So again, this is Richard Earnhardt. I'll continue with problem number 18 under basic mathematics. If sine A is equal to 2.5x and cosine x is equal to 5.5x, find the value of A in degrees. Okay, so we divide sine A by cosine A. That is equal to 2.5x over 5.5x. So x here will cancel out. Okay, so but sine A over cosine A is tangent A. So this is 2.5 over 5.5, and get the arctangent of 2.5 over 5.5. That is 24.4 degrees. Okay, so the answer here is letter C. Okay, now we have arctangent x plus arctangent of 1/3 is equal to pi over 4. Okay, we're solving for x here. Now note that this is constant, no? So we can transpose this to the right hand side. So this is minus arctan of 1/3. Now if we want to solve for x, no? So therefore x is equal to tangent of pi over 4 arctangent of 1/3. Now since we're dealing with real, now these are real numbers, no? So the mode should be in radian. Okay, and from your calculator this will give you 1/2. Okay, around 1/2. Okay, so the answer here is letter D. If A is in the third quadrant and cosine A is negative 15 over 17, so find the value of cosine A over 2. Okay, so we can solve this even without applying the double angle identity for cosine function, no? Because we can from cosine A negative over 17, we can actually compute for A here. So arc cosine of A will give you the angle arc cosine of negative over 17. Okay, the angle here is 151.95 degrees. Okay, A must be in the third quadrant. Now 1.95 is in the second quadrant. So how do you find the angle in the third quadrant? We get the reference angle, okay? Yung reference angle nito, which is 180 minus 151.95 degrees. And that is 28.05 degrees, and therefore angle A must be 180 plus the reference angle. So this gives you 208. Okay. 0.05 0.05 degrees, and we use this angle, the angle in the third quadrant, to compute for cosine A over 2. So this is cosine of 208.05 divided by 2. Okay, so check your calculator. The mode should be in degrees. Okay, kasi from the last problem we set the mode to radian, so set back or set again the mode to degrees, and we expect the answer to be negative 0.2425. Okay, so among the choices, this is equivalent to negative of square root of 1 over 70, no? So that is letter A. That's a problem 21. If A plus B plus C equals 180 degrees, then the sum tangent A, tangent B, tangent C is equal to 5.67. So find the value of the product tangent A, tangent B, tangent C. Okay, so from this equation, no, we get the tangent of both sides. So tangent of A plus B plus C is equal to tangent of 180 degrees. Okay, and then we combine this one, apply tangent of the sum of two angles, so that will be tangent of A plus B, okay, plus C. Tapos this will be equal to 0. Tangent of 180 is 0. And then tangent of two angles will be tangent of A plus B plus tangent of C all over 1 minus tangent of A plus B times tangent of C equals 0. Now if you cross multiply or multiply this by 1 over tangent of A plus B times tangent of C, so you get 0 here on the right hand side, and then giving you only tangent of A plus B plus tangent of C. So that will be tangent of A plus B plus tangent of C equals 0. And then again, tangent of A plus B is tangent of A plus tangent of B over 1 minus tangent of A times tangent of B. Okay, plus, and then we can transpose this to the other side. Okay, so negative tangent of C. Okay, and then we cross multiply here, so I get here tangent of A plus tangent of B, and then cross multiply here, so I get negative tangent of C here times 1, you know, so, and then minus minus, so that gives you a plus, then product nito, tangent of A tangent of B times tangent of C. But we're given that this sum is, so transpose this one, so we get tangent of A plus tangent of B plus tangent of C is equal to tangent of A tangent of B plus tangent of C. But this one is 5.67, no? So therefore, okay, the product, this is product pala, not sum. Okay, so the product of tangent A, tangent B, tangent C is also equal to 5.67. Okay, okay, so this is a logarithmic equation. So we apply the logarithmic properties. Okay, we simplify everything first. So this is log of 4 raised to x. Okay, you have log of 4 here. Okay. This is, okay, log of same base, and this is plus, so log of the product, log of 4 times 32 plus 4x. Okay, we can simplify this. Actually, you can compute this directly from your calculator, but this problem will somehow review your logarithmic properties. The method here will recall the logarithmic properties. So this is log of the product 6 times 4 raised to x, and then you have log of 4 times 32 plus 4x. As you can see, if you have the same base, logarithmic of the same base, you can equate. Okay, 6.4 raised to x and 4 times 32 plus 4 times 4x. Okay, so you have here raised to x divided by 6 32 times 4 divided by 6. Log, okay, log of product, log of sum is log of the product. Okay. Wait, this is 4x pala. Kaya pala. Sorry. We can actually combine this one, as the coefficient. So transpose this one here. So that will give you 2 times 4 raised to x. 6 minus 4 is 2. Okay, tapos here we have 4 times 32. So 128. Okay, divide by 2 will give you 4 raised to x equals 128. Divide by 2. So that will be 64. And 64, okay, is, wait, so this is 4 times 4 times 4, so this is 4 cubed. Okay, this is 4 cubed, and therefore x must be equal to 3. So the answer here is 3. Okay. So what quadrant is A if secant A is positive and cosecant A is negative? Okay, so let's see. Your secant A is positive, and the reciprocal of secant is cosine, and cosine is positive in the first quadrant and fourth quadrant. Okay, cosecant of A is negative. Cosecant, the reciprocal is sine, and sine is negative in the second quadrant. Cosecant is negative in the or rather sine or cosecant is negative in positive in the first quadrant and second quadrant, so therefore third quadrant and fourth quadrant. Okay, so the common angle here is 4, so the answer must be 4. No? So the angle must be in quadrant 4. A man finds the angle of elevation of the tower of a tower to be 30 degrees, so he walks 85 meter nearer the tower and find its angle of elevation to be 60 degrees. So what is the height of the tower? Okay, so let's say this is the tower. Okay, so this is the eye level of the man who sees that the tower is, the angle of elevation of the tower is 30 degrees, or the top of the tower is 30 degrees. Now if he moves 85 nearer, so this must be 85 meters. So let's say this is A, this is point B, C, letter D. Then the angle of elevation becomes, this one is 60 degrees. Okay, so let this be X. Now take note that the tower makes, we assume that the tower is vertical and it makes a right angle, no, with the eye level of the man. So we're asked to find the height of the tower. Say that is letter H. So with triangle DCB, okay, we get H over X as tangent of 60 degrees. And tangent of 60 degrees is square root of 3. So therefore your h is square root of 3x. Or shall we say x is equal to h over square root of 3. Okay, so let this be your first equation. And then from the triangle DCA, okay, so h over x plus 85 is tangent of 30 degrees. Okay, so we have here h, okay, tapos tangent of 30 degrees. We cross multiply, but x here is h over square root of 3, so plus 85. So this one is your x, no? And then we can now solve for h. Okay. So we have 1 minus tangent of 30 over square root of 3. Okay. And then 85 times tangent 30 degrees. Now divide by 1 minus h over square root of 3. So 85 times tangent of 30 degrees. Okay, so that gives you 73.61. And that is letter A. Now let's have problem number 25. So points A and B, 1,000 meter apart, are plotted on straight highway running east and west from A. The bearing of a tower C is 32 degrees west of north, and from B the bearing of C is 23 degrees north of east. So approximate the shortest distance of tower C to the highway. Okay, so let us draw first the figure. Okay, so we have let's say point B, and this is point A. So this is the east and then west. So from A, the bearing tower of C, the bearing of a tower C is 32 degrees west of north. So draw here your north, and then up. Sorry, this is A. So your north. Okay, from A, and then tower is 32 degrees west of north. So the reference will be north, no? So this is letter C. So this angle is 32 degrees, no, from north. Okay? From north. And then from B, north of east. Of east. So the reference will be east. The bearing of C is 26 degrees north of east. So from east, this is east, So the angle must be, so this must be your 26 degrees. Okay. And if this is 32, this angle must be 58 degrees. Okay. And this is the shortest distance now. Must be perpendicular to BE, or rather BA. So this is, let's say, Y. Okay. So if that is 1,000 meters apart, so if this is X, the other distance should be represented by 1,000 minus X. Okay? So you have two right triangles here. So Y over X is tangent of 26 degrees. We want A, no? So we have X over Y over tangent of 26 degrees. And to the other triangle, we have Y over 1,000 minus X equals tangent of 58 degrees. Okay, so therefore Y is equal to tangent of 58 degrees times 1,000 minus your X is Y over tangent of 26 degrees. So you can now compute for Y here. Okay. Ayan. So this, your Y here must be 373.8 meters. Okay, so for 374 meters, so the answer must be letter C. If an equilateral triangle is circumscribed about a circle, no, of radius 10 centimeters, determine the side of the triangle. Okay. The triangle is circumscribed, so the triangle must be outside. The equilateral triangle must be outside the circle, no? Okay, now if this is equilateral, then the sides are equal. Okay, and from the center to the opposite side, this is the radius, so, and that is perpendicular. Okay, perpendicular to the side of the triangle. And R is given to be 10 cm. And since this is equilateral, 60 degrees yan, and then this side must be a bisector, so this is 30 degrees. And this side must be X over 2. So using this triangle, okay, right triangle, okay, so R is 10, so 10 over X over 2 is equal to tangent of 30 degrees. So we can solve for X here, which is 34.64. So this is the required answer. Or you can use the relationship, no, for the relationship between the inscribed circle or the circumscribing triangle. Okay, using the relationship that the radius of the circle is equal to the area of the triangle divided by the semi-perimeter of the triangle. So if the radius is 10, so we have 10 here, the area of an equilateral triangle is 1/2 x squared. X is the common side, and then sine of 60 degrees. Okay, sine of one angle, which is 60 degrees. And then the semi-perimeter will be, okay, sum of all the sides, which is 3x divided by 2. Okay, and you can verify that this is also 20 square root of 3 or 34.64, okay, centimeters. A ship started sailing south or west of south, so this is read as west of south, 42 degrees 35 minutes at the rate of 5 kph. After 2 hours, the ship B started at the same port going 46 degrees 20 minutes west of north, no? At the rate of 7 kilometers per hour. So after how many hours will the second ship be exactly north of ship A? Okay, so let's start with, okay, the position of the port. Okay, let's say this is point P. Okay. This is your north, okay, south, west, and then east. So this is west of south, so the reference will be south, no? And so this is, let's say, the final destination of ship A, okay, and the bearing is 42 degrees. So this one is, okay, 42 degrees 35 minutes, no? West of south, so the reference will be from the south. And this is 5 kph, so the distance from AP will be 5. Okay, the rate multiplied by the time. So let's say the time is t, no? The time travel of ship A from point P to point A. Okay, and then ship B started after 2 hours, and it goes in this direction, no? West of north until B is north of A. So let's say, so this is the direction, no, where B is north of A. So maybe somewhere here. Let's say this is the final destination. And then this angle is west of north, so the reference will be from north, no? So that angle is 46 degrees 20 minutes. And definitely this is also 46 degrees 20 minutes, and this one is 42 degrees 35 minutes. Now this forms an oblique triangle. Okay, maybe we can use Sine Law. By the way, the distance from P to B is the velocity, which is 7, and then the time is t minus 2, no? T minus 2. So the time is represented by t minus 2 for ship B. And by sine law, let's start with 5t. 5t, so this is the distance, no, over sine of the opposite, which is 46 degrees, 20 minutes. And the distance from P to B is B times t minus 2, and then the opposite angle is 42 degrees, so sine 42 degrees, 35 minutes. And okay, compute. Okay, we compute for t, and your t here is 6.63. Okay, so we're after t minus 2, so the answer must be 0.03 hours. Okay, so this must be the correct answer, letter C. A spherical triangle ABC has an angle C equals to 90 degrees and sides 50 degrees and C 80 degrees. So find the value of B in degrees. Okay, so this is a spherical right triangle. Let's say, okay, this is your right triangle, and the opposite side is 80 degrees. Say this is angle A. The opposite of angle A is 50 degrees. That's given. Okay, so B here is unknown. Also the opposite side. Okay, now let us draw our Napier circle. Okay, so note that A and B are adjacent, no? So A and B, so let's say ito yung ating A, which is 50 degrees, and then unknown B. This is what we want to know. Side B. Okay, the opposite of A is co-A, and then opposite of B is co-B in the Napier circle, and then this is your co-C or co-80 degrees. Okay, so we're given here A and C. So these two parts, and we're asked to find this part or side B. So your Napier's rule, no, will involve these three parts, no. So if you take this as the middle part, okay, A and B, the sides A and B will turn out to be the opposite sides. Okay, so in the Napier's rule, the sine of the middle part is equal to the product, no, of the opposite parts. So therefore this is sine of co-80 degrees cosine of 80 degrees and cosine of B. Now, the co-function of sine is cosine. No? So, this has to be cosine 80 degrees. A is 50 pala. This is 50. So, you have cosine 50 degrees, cosine of B. And from here, you get side B, which is 74.33 degrees. And that is letter C. The area of a spherical triangle ABC whose parts are given A, B, and C, the angles, interior angles, and then the radius of the sphere is 100 meters. So, the area is equal to the formula for the area of a spherical triangle is pi times the spherical excess, that's E, r squared, r is the radius, divided by 180 degrees. So the spherical excess is just the sum of the three angles, no? Then minus 180 degrees. So sum of the three angles, then minus 180 degrees, and that gives you 94.72 degrees. So therefore the area is equal to pi times 94.72 degrees times 100 squared divided by 180 degrees, and you should get here 16,531 square meters, and that is also letter C. What is the volume of a hexagonal right prism 15 centimeter high and with one of its sides equal to 6 centimeters? So let us draw so regular hexagon, you have 6 sides. Okay. Okay. The height is the distance, the parallel distance between the two bases, and that is given, and one of the sides of the base, so obviously referring to the base edge, is 6 centimeters. Now the volume, we're asked for the volume, okay, of the hexagonal right prism. The volume is equal to the base area multiplied by the height. So this is also the base area. Okay, and this is the area of a regular hexagon. The area of a regular hexagon is given by the formula n squared over 4 tangent of 180 degrees, divided by n. So this is, we have 6 sides, for hexagon, and then the measure of one side is 6, so quantity squared divided by 4 tangent of 180 degrees divided by 6. Okay. And this is 54 times square root of 3. So therefore the volume is equal to 54 times square root of 3 times 15 centimeters, which is the height. So this gives you 1403 cubic cm. Okay, and that is also letter C.